In this video, I'm going to be showing you how to solve a system of linear inequalities. Now first I want to remind you how to graph a linear inequality. So let's say I have the equation y is less than 1/2 x minus 4. Okay. You start by graphing it like you would any inequality, or any equation rather. You start at the intercept, so go down 4, and my slope is positive 1/2, so up and over, up and over. Now, what you do have to be careful of though is your inequality symbol. There's two things that you have to take from which inequality symbol you're using. The first is what type of line are you going to be drawing? Is it going to be dotted or solid? If you have less than or greater than, it's going to be dotted. If it's the or equal to's, you're going to use a solid line. So in this case, because it's just less than, I'm going to use a dotted line. The second part is shading, because there's not just one answer to an inequality. There's an infinite number of solutions, because it's any x value that gives you a number less than whatever y value we have on our graph. So if you have less than, you're going to shade below your line. If it's greater than, you shade above your line. So this is less than, the shading would be below the line. Now what happens if you're not sure? Well, pick a point and test it. I like picking the point 0, 0. So let's say I tested the point 0, 0 with this inequality. 0 less than or equal to, if I plug in a 0 here, I'm going to get -4. But this is not true. 0 is not less than -4, so this is on the wrong side. I shade the other side. If it was a true statement, like if I picked any point in this shaded area, so let's say 0, -6. If I plug in 0, -6 in here, I get -6 less than -4. Well, that's true, so that's the correct side to shade on. Now, let's look at another example. Let's look at y greater than or equal to 3x. No intercept, so it starts at the origin. I go up 3 over 1, 3 over 1. Okay, and when I look at this, or equal to means I'm going to have a solid line, and not very straight, but just bear with me here. And the shading, well, it's greater than, so greater than's above. And again, if you're not sure, pick a point on one side, plug it in, see if it's true or false. True, that's the correct side. False, shade the other side. But greater than, in this case, is going to be that side. So you shade this side of the equation. Now, the title of this video is Systems of Linear Inequalities. What I've shown you is just one. So, a system of linear inequalities is when you have more than one inequality graphed on the same plane. So, let's take, I guess I can just make up some equations here. Let's say I have, alright, 9x plus 12y equals -60. And on my other one, let's say I've got, oh, it shouldn't be equals. So greater than -60. On the other ones, I'm going to make it easy on myself. Y less than or equal to, I don't know, 3x plus 1. I am going to change one thing. I'm going to make this negative. There's a reason for that. I'll show you in a minute. So the reason I wrote this one this way is to show you that sometimes it's not in slope-intercept form. If it's not, that's the first thing you need to do, is put it in slope-intercept form. So in order for me to graph this, I first have to subtract 9x from both sides. Okay? When I subtract 9x from both sides, I'll get negative 12y greater than negative 9x minus 60. But then I have to divide by negative 12. Whenever you multiply or divide by a negative number, you have to flip the inequality. So 9/12, that would be 3/4 x plus 5. Alright, so now I take these and I graph them. For the first one, 3x plus 1, we'll go up 1, and then slope is 3 over 1. So 3 over 1, I'm going to go both ways. Since I don't have a straight edge handy, it makes it easier for me to draw my line. This one is going to be a solid line. And I am going to be shading below because it's less than. Now, you don't have to color in the whole thing. Doing this is just enough. In fact, I like to do horizontal lines for one, vertical for the other, so I can see where they meet up a little bit easier. Now, for the other one, it's 3/4 x plus 5. So I'm going to go up 5. 1, 2, 3, 4, 5. And 3/4 means I can go up 3 and over 4. Up 3 over 4. Or I can go down 3 over 4. That works too. And again, I'm going to do multiple because I don't have a straight edge. And this one is going to have a dotted line because it's just less than. So dotted line. And I am shading below because this one is also less than. Now you can see that in this area right here, my shaded areas overlap. So the solution is in this portion of the graph. Now let's say you wanted to check, you didn't have the graph, you just had these, and you wanted to check to see if a point was a solution to both to the system. What you have to do is you take the point, let's say that one, and plug it into both equations. See if it both comes out true. If even one of them is false, it's not a solution. So this point would be true for both of them. If you want to test yourself, you can actually plug it in, but I'm just kind of telling you that's 1, 2, 3, 4, 5, 6. So that's the 0.60. If I plug in 6 for x, 0 for y in both of them, it'll come out to be true. But let's say that I plug this point in. It's going to be true for the second equation, but not for the first. Or if I plug this point in, it'll be true for the first, but not the second. So these points are not solutions to the system. Alright, so I think that covers most of the things you'll see for systems of linear inequalities. If you have any questions, please feel free to ask in the comments.